Okay, so we're going to talk about multiplying and dividing rationals. We went through the basics of it before, and we realized that the shortcuts were that when you're multiplying rationals, the rule is to multiply straight across. And we drew area models to represent that, and we also know that when you're multiplying straight across, it's not like adding and subtracting. We have no common denominator needed. No common denominator needed. Okay, and dividing is the inverse multiplying, and so whenever we're trying to divide rationally, we want to cancel off what we're dividing by and change it to multiplication, which we realized meant that when we're dividing, we want to reciprocate, which means flip the fraction. So reciprocate the divisor, and when I say divisor, that means what you're dividing by. So over here, for instance, we're taking 3/4 and dividing by 2/3, then that means we're going to reciprocate the 2/3 and make it 3/2, and it would then change to a multiplication problem. Okay, so let's go through the basics really quick again, just to remind ourselves what this looks like. So if I take 3/4 times 2/3, the rule is to go straight across, which means we're going to attach the 3 with the 2 and the 4 with the 3. And when I look at this already, we can see that something is going to divide out. We have that common factor of 3 happening. So I could divide out the common factor of 3, and we're left with 2 4s. But 2 and 4 also have another common factor, which is 2. So we could divide out a 2, and we'd be left with a half. Okay, on the next one, when we're dividing, we said that we're going to reciprocate and change it to multiplication. So we keep that first fraction and change this to multiplication by reciprocating the 2/3 to make 3/2. And now follow the same process as the previous problem, where we attach the factors straight across from each other. So 3 is attached to 3 and 4 is attached to 2. But we don't have any common factors that divide out right now. And even when I multiply these, 3 times 3 is 9, 4 times 2 is 8. Again, 9 and 8 don't have any common factors other than 1. So then this will not simplify any further than 9/8. And it's okay to leave these as improper fractions, because when we get to rational expressions down here, it's kind of hard for you to determine what makes a whole. We're just going to leave things as improper fractions. All right, so let's go through the 3 steps of what we need to do whenever we have rational expressions instead of just the basic fractions. So to make this process a lot easier, we kept saying that we were going to attach these values to each other, but we want them to be factored already. That way we can go straight to simplifying. So the first step is to make sure every expression inside the fraction is written in its factored form, as factored as you can get it. So let's go ahead and do step 1. So step 1, we're going to factor every single expression here, which should be very easy for us to do, because we know that the a value of each of these is 1, and we do not need to do factoring by grouping. We can just use our shortcut, knowing that we have to multiply to get -16, since that's a times c, and we have to add to get -6, since that's our b. And we know these factors would end up being 2 and -8. So then rewriting our factored form, we would have x plus 2 and x minus 8 replacing the first numerator. So over here, we're going to rewrite our fraction with x plus 2 times x minus 8. And do the same exact rule for the denominator. We're going to factor that one as well. So do your big X puzzle. We multiply a and c. A times c is -21. And our b value is +4. So we would want to use -3 and +7. So we would get x minus 3 and x plus 7. And we'll replace those factors in our denominator. X minus 3 and x plus 7. Okay, so similarly, we would factor the other two the same exact way. I'm going to save us some time and just factor them for you. On the numerator here, we would end up with x minus 5 and x minus 3. And then in the denominator here, we would end up with x plus 2 and x plus 7. All right, so that was step 1. And now that everything is in its factored form, it makes this easier because just like before, we know that we multiply straight across and we attach the values to each other. We're going to do the same process. We are going to attach each of these factors that are straight across from each other. So basically, this is all going to turn into one giant fraction. We are going to multiply straight across from each other. We have x plus 2, x minus 8, x minus 5, x minus 3, all being multiplied to each other. And then in the denominator, we have x minus 3, x plus 7, x plus 2, x plus 7, all being multiplied. No common denominator is needed. So the third and final step is we want to see if we can simplify this expression, which we've already learned. In order to simplify, we divide out any common factors that we see. So it's obvious that we have some common factors. We have x plus 2 dividing by itself, and we also have x minus 3 dividing by itself. And then what's left over would be x minus 8 times x minus 5 all over x plus 7 times x plus 7. And I have a few people that say, well, hey, can I do something with those x plus 7s? No, you cannot cross these x plus 7s off because they are not dividing by each other. They're multiplying. And in fact, they're multiplying by each other. So when we multiply something by itself, we usually use the word squaring. So another way that you could see this being written out would be x minus 8 times x minus 5 all over the value x plus 7 being squared. These mean the exact same thing because you're multiplying x plus 7 to itself. And then from here, you would not be able to do anything further. Now, if you get to this next expression where we're dividing, you still want to follow the same thing. You just have to remember to reciprocate the divisor. And notice, when I reciprocate this divisor, and I rewrite my expressions now, and it turns into multiplication, I want you to look at my expression and then look at the one that we just did over here. If you notice, these are the exact same problems now. The only thing I did extra from the beginning was reciprocating. That will not always happen. I just did this to point out to you that you're going to follow the exact same 3 steps as multiplication. You just have to remember to reciprocate what you are dividing by. So once you are trying to simplify this, you would follow same 3 steps. So basically, if I were to finish this problem, I would get the exact same solution as over here. All right, so let's go ahead and flip this over. And I'm going to choose some random one because I got some blurred out ones. They're not very easy for you to see. But I want to go to number, let's look at number 3 and possibly number 4 if we have time. Okay, so on number 3 down here with the dividing, I'm sorry if it's blurred out and it's really hard to see. But I'm going to go ahead and factor with these. So we know that these have that a value of 1, like I showed you. And we're dividing, so we know that we're going to have to end up reciprocating. So if I rewrite this, this would all then become x squared minus 7x plus 6 over the x squared minus 1. But then it's going to become a multiplication problem instead of a division problem. So now we want to make sure everything is written in its factored form. Well, each of these expressions has an a value of 1, which makes it easy for us to factor. And so does this one, but instead of using the a equals 1 rule, we notice that this is a difference of squares. And we have that difference of squares formula where if you have something written as a squared minus b squared, the factors will be a plus b times a minus b. You just have to figure out what those bases would be before you can write it, which we've done before. All right, so let me go ahead and give you the factors. We're just going to practice simplifying. So the factors of this one using a equals 1 would be x plus 1 times x plus 1. Factors of the denominator would have been x minus 6 and x plus 3. Then the factors of this numerator would have been x minus 6 and x minus 1. And now if we're using our difference of squares formula that I just showed you, we want to be able to square root these values to make sure that we can find the a and the b base, but this one's super easy. The square root of x squared, we know our a value would be x then, and we know our b value, if I take the square root of 1, it's a perfect square. We could rewrite 1 as 1 squared. So my a would be x and my b would be 1. Therefore, the factors would be x plus 1 and x minus 1, which makes this awesome now because in step 2, we just attach all these factors. Instead of rewriting it, why don't you just go ahead and connect this division sign right here, the fraction bar. Connect it, and now it's all one giant fraction, and we can cross off any common factors that we see, which would be the x minus 6, and the x minus 1, and the x plus 1, but you cannot cross off more than the x plus 1s at the top because you can only divide out each common factor. We don't have double of the common factors in the numerator and denominator. So that x plus 1 will still stay in my numerator, and we would leave it as x plus 1 over x plus 3. So I want you to just keep in mind, because class is about to end and I start my next one, but sometimes all you have to do to factor would also be like GCF, because here we have 4x minus 6. To factor that, all you could do is pull out a 2 and you'd be left with x minus 3. And then there's nothing else you could do to factor this expression since there's no other exponents to expand out or any other common factors. So sometimes it's as easy as just pulling out a greatest common factor, and that's all you can do to factor. Or sometimes, like over here where we have x minus 2, you can't do anything with x minus 2 because there's no common factors or no exponents to expand. Same thing if you had a value that's by itself, like x cubed. There's no terms being added or subtracted. You're not going to be able to expand out x cubed anymore other than writing x 3 times being multiplied. So sometimes factoring is not an issue. It just becomes an issue whenever there's a lot of messy work. So a good thing is to stay organized, but just know that dividing and multiplication are very similar. You want to factor everywhere possible, attach the factors, and then divide out any of the common factors. If you need help with factoring, please come see me. All right, have a nice day.